Welcome to video 7 in the A1 series. In this video, we'll be looking at the basic formulae and equations of projectile motion in 2 dimensions, looking at how to calculate maximum height, the time to top, the total flight time, and hence the range. And then we're looking at a straightforward level ground question. Then we'll be looking at all the remaining practice questions, 19, 20, 21, 22, 23, 24, and 25, which makes this video quite long. And we'll be finishing with me setting you a little homework exercise, which we'll go through next time. Please enjoy. Hello and welcome back to A1.007. Today we're really going to get our teeth into projectile motion in 2 dimensions. Let's start with the absolute basics. The time to top. That means the time to the top of the throw when you throw a projectile. Do you agree that if I were to throw something vertically up at 20 meters per second, weight, gravity, will be slowing it down by 10 meters per second every second. So the time it will take to stop when it's at the top will be its initial vertical velocity. So I'm going to be using U with an arrow going up. So it's the vertical component of its initial velocity divided by G. And we're going to be using 9.8 for G. Do you also agree that if you start at 20 and you finish at 0 and your acceleration is constant, then your average will be the halfway mark. It'll be vertical component of U divided by 2. And therefore the distance that you will travel as you go up will be average speed times time, which is, average speed is this, divided by 2, times vertical component over G, which is vertical component squared, divided by 2G. And this is really important. Assuming that the ground is at the point where you threw it up, the maximum height above the ground, or the maximum height above where it was thrown, to be more precise, is initial vertical velocity squared divided by 2G. And this is such a useful little equation. So the maximum height achieved is always the vertical component squared divided by 2 times G. I hope that's all clear. So here's my very first worked example on projectile motion in 2D. It's a golfer. They hit a golf ball from level ground at an angle of 51 degrees to the horizontal, and they hit it at 55 meters per second. The ball goes up in the air, reaches a maximum height, and lands way over there. And what I want you to tell me is what is the maximum height it's achieved, and what is the range. Now in physics, the range is always the horizontal distance from where it left to where it arrived. So that's the range, and I want to know the range in meters. How are we going to do this? Well, the first thing we're going to do is 55 meters per second is of no use to anyone. We have to resolve this into vertical and horizontal components, and that usually gets you a mark in your question. So let's do that right away. Initial vertical is equal to, you remember this now, sine 51 degrees times 55 equals, and horizontal initial, which is fixed for its entire duration, is going to equal cos 51 degrees times 55 equals. Let's do that in a calculator. Write them down to two significant figures. Let's go. Sine 51 multiplied by 55. 42.74. I suggest that you keep it to two decimal places while you're working things through. Cos 51 times 55, 34.61. 34.61. That's up and that's sideways. That gets you 2 marks usually. Next thing we're going to do, I want to work out that, the maximum height. Well, we have a very quick and easy formula for that. Maximum height equals, altogether now, vertical component squared divided by twice gravity. So the vertical component, 42.74 squared divided by brackets 2 times 9.8, close brackets, 93.2. It's going to go 93.2 meters in the air. How long will it take to get to that point? Well, we all know the answer to that. It's that. That's the time taken. And so that's 42.74 divided by 9.8. 4.36 seconds. Again, this is really important. If it takes 4.36 seconds to go up, it's going to take exactly the same to come back down. If it's what we call a level ground question, which is what most questions are, these are straightforward ones. So, total flight time, TFT, the total time it takes to get from there to there, is going to equal, for a level ground question, 2 of those. 2 lots of initial vertical component divided by g, because that is the time up, and so it's the same to come down. And that should be learnt. TFT equals 2 vertical component divided by g. So in this case, 4.36 times 2, 8.72 seconds. 8.72 seconds is total flight time. And we know that during this entire time, it's going sideways at 34.61 all the time. So if we just multiply TFT by that number, it'll tell us the range. Range equals initial horizontal, which is the same as, it doesn't change anyway, multiplied by TFT. The range is the initial horizontal velocity multiplied by TFT, total flight time. 8.72 seconds times 34.61. 301.8 metres. Call it 302 metres. That's probably a bit too much for a golf, but never mind. The next thing you need to know is that with a level ground question, because when it hits the ground, the horizontal component is unchanged and the vertical component is exactly the same as it was when it left, because remember, the speed up equals the speed when you come down, just in the opposite direction. Which means that okay, let me just go back. When you took off, you were going sideways and you were going up at a particular angle theta. When you hit the ground at the other end, you're still going sideways at the same speed, but you're now going downwards at exactly the same speed as you're going up when you started, which means that these two triangles are the same, which means the angle of impact there with the horizontal is the same as the angle it left. So that's going to be 51 degrees. So for level ground questions, the angle of impact is always the same as the angle of departure. It won't be for others, but it is for level ground. Okay, welcome back. We're going to do practice question 19 now. Practice question 19 is a really nice question that makes you think about what's going on. They give you 2 projectile routes. The first one is steeper than the second one. They both go up to the same height. And it asks you which quantity has the same value for both projectiles, and they give you a choice of 4. First things first. The one thing you do know is they both got to the same height. If they both got to the same height, they must have one thing in common. They must both have exactly the same vertical component on departure, the same initial vertical component. We know that whatever the vertical component for this one is exactly the same as the vertical component for that, because we divided it by g to give the time to the top, and they all arrived at the top at the same time. So this one arrived there at time t, and that one arrived there at time t. They arrived together because they were both going up at the same vertical speed. They also, interestingly, both arrived back down. So, straight away, I'm giving the answer here. If it took the same time to go up and the same time to go down, they must all have had the same time of flight. So the answer is B. You're probably thinking, hang on, what about the other stuff? Surely that's also initial speed. You're probably thinking, well, how do you know they weren't the same initial speed? Well, because, do you agree, their vertical component was exactly the same, but this one's at a different angle from that one. So this one must have had a greater horizontal component than this one, because they both have the same vertical. If this is different, then when you put it back together again, this one must be going faster than this one, So it's not initial speed because that one's going faster than that one. Horizontal component of initial velocity? No. This one has got a higher initial component of horizontal than this one. Speed at maximum height. Interesting. They're both at the same height, but this one's going sideways faster than that one. So no, it's not the same. It's the same vertical velocity at maximum height, 0, but no, that one is going sideways faster than that one. So the answer to question 19 is definitely B. I hope they're okay with that. Okay, so we're going to have a go at practice question 20. We are told that an arrow is fired from a height h horizontally and it goes and lands a distance s. We are then told that a second arrow is fired from a greater height, also horizontally, also at the same speed, but it lands 2 times further away. And they want to know how much higher was it in terms of h. Before we do that, I want to show you this. Let's do a very simple chart of what happens to a falling object, and we're going to round it to 10 rather than 9.8. So time 1 second, speed 10. You know that a falling object accelerates by 10 meters per second every second. And what we're going to do is we're going to work out the average speed. If the speed after 1 second is 10, what was the average speed? The average speed is half that. 5, 10, 15, 20, 25 and 30. And what was the distance it travelled during the journey? Distance is average speed times time. 1 times 5, 5, 2 times 10, 20, 45, 80, 125, 180. Now notice something. If the time doubles, what happens to the distance? It falls. The time doubles, the distance it falls goes up by 4. Look, that's a doubling, and that's 4 times. If I go from, say, 2 to 4, I've gone from 20 to 80, which is 4 times. If I double the time from 3 to 6, I go from 45 to 180, which is 4 times. Going back to this question, if the horizontal distance has doubled and everything else is basically the same, you know that total flight time has doubled. Right, so it was in the air twice as long. We don't need to worry about this 2s here so much. Do you agree that we have determined the time taken for the journey must be 2t? What's it doing during this journey? It's falling. And we know that if you double the time for a drop, what happens to the distance? It goes up 4 times. So this new height must be 4h. And the answer is D. 4h. Okay, one more time because this is tricky. First thing, because it's gone twice as far horizontally, it must have been in the air twice the time. But if you look at my little table, if you fall for twice the time, the distance you fall is 4 times. So it must have fallen 4 times. So it must have fallen a distance of 4h. So the answer is 4h. I hope that's clear. Okay, so welcome back. We're doing practice question 21. A rock is thrown vertically downwards from a tall tower at 4 meters per second. It hits the ground 1.9 seconds later, and we have to determine the distance it's fallen. Let's write down SUVAT and see what we have. Firstly, before we do that, let's make, now, this is the one example where I'm prepared to make everything positive simply because there is nothing's being thrown up. Now normally with projectile questions I'm always telling you we go up positive, but here there is no up, nothing's going up. So we're going to have down as positive just this once. Okay, so S we don't know. U is plus 4. V we don't know. Acceleration, this time, because we're going down, 9.8 meters per second. Time, 1.9 seconds. What do we want? We want that. So we want a formula which doesn't have V in it, but has all the others. S equals UT plus half AT squared. S equals 4 times 1.9 plus a half 9.8 times 1.9 squared. I suggest you chunk it on your calculator, which I'm about to do. That's 7.6. A half times 9.8 times 1.9 squared is 17.7. Add them together, I get an answer of about 25 metres. And in the book, oh looky, D, answer D, 25 metres. There you go, straightforward. Using this, you've been given T, it's just a lot of work on the calculator. 25 metres is the answer. Okay, so welcome back to PQ21. A little ball is rolling along. It comes off the edge of a table and falls down there. You are told the height of the table is h, and you want an expression for the range, the horizontal distance from there to there. Now you know from previous things that the range is the initial or the horizontal component of motion times total flight time. But we're not provided with any of that information other than this. Where are we going to get total flight time from all of this? You know that vertically speaking, the distance you fall, s, which in this case is h, I guess, h is equal to ut plus half at squared, where u is 0. That's half g t squared. G is acceleration. So h is half gt squared, right? What we need to then do is to rearrange this to try to get t out of it. So we need to rearrange that. So do you agree that 2h equals gt squared? T squared would equal 2h over g. So the time to fall down would be root 2h over g. So if I multiply the time fallen by the horizontal component, I'll get the answer. And that is root 2h over g times what they called v is c. And so the answer to the question is C. Okay, and welcome to PQ23. A football is kicked. It goes up in the air and comes back down again. We are told two pieces of information. We are told that after 0.9 seconds, it's reached the top of its flight, and that is a horizontal distance of 16 metres. Question part A, calculate the vertical component of the initial velocity. Well, just going back to things about time to the top, we know that time to top is equal to initial vertical component divided by g. And we know that that equals 0.9 seconds because we are told. So if we take 0.9 and multiply by g, it should tell us what the initial vertical component was. We're going to use 9.8 here. So 8.82. 8.82 vertical component. Its initial speed. That's an interesting one. Well, we know its horizontal component. Its horizontal component is that it went 16 metres in 0.9 seconds. 16 divided by 0.9 is it was going sideways, horizontal, 17.8 metres per second. Now if I give you two components, that's 17.8, and going up is 8.82. We've now got a Pythagoras situation, and to work out the hypotenuse, which is the speed at which it left, we just use Pythag on that. 8.82 squared plus 17.8 squared, square root the answer, 19.86, 19.9. 19.9 metres per second. The angle to the horizontal at which it leaves the ground, well, the angle to the horizontal, back to this triangle here, that angle there is the tangent. So if I divide that number by that number and then arctan it, I'll get the angle. So shift tan 8.82 divide 17.8, close brackets, equals 26.3 degrees. 26.4 degrees. Okay, that's part C. And its maximum height. Well, we know maximum height. Maximum height is vertical component squared over 2g. And we know its vertical component, 8.82. 8.82 squared divided by brackets 2 times 9.8. Oh, 4 metres, 3.97 3.97 metres. So that's question 23. You had to use a tangent, you had to use an arctan, otherwise it was just thinking about where the numbers come from. Thank you. Welcome back to PQ24. A tennis player hits a ball horizontally, 2.7 metres above the ground, and 12 metres away is a net, that's 0.9 metres high. And we have to find out the minimum initial speed for the ball to get over the net. The easiest way of looking at this is what's going to be happening to the ball vertically from the moment it leaves to the point it gets to the net, where it's going to be falling. Do you agree that the vertical distance that ball is going to fall is going to be the difference between 2.7 and 0.9, which is 1.8. So it's going to fall 1.8 metres. Where something is falling and the vertical component was 0, we know that s equals half at squared. So 1.8 metres is a half times minus 9.81. We'll take the minus off, don't really need that, times t squared. So we can find t. Don't need to worry about the sign on that. Okay, so we get our calculator out. 1.8 times 2, divide by 9.81. Square root answer, 0.606, that'll do. 0.606 is how long it's going to take to fall 1.8 metres. Let's double check the number just to make sure everyone's happy here. A half times 9.8 times 0.606 squared times 0.5, 1.8 metres, that's correct. So that is the time in seconds that it will take the ball to fall vertically to the height of the top of the net. So it better get there in that time, hasn't it? So its speed, its horizontal speed, must be 12 metres divided by that. So it must be going at 19.8 metres per second. There's no extra work to be done because you know the vertical component was 0. Because you're told it was going horizontally. So determine the minimum initial speed of the ball so that it passes above the net. And the answer is 19.8 metres per second, so that when it falls 1.8 metres, which it will take that time, by that time it must be there. So you know its speed. I hope that's okay. Okay, so welcome back to PQ25. Olaf throws a dart at 9 metres per second at an angle of 4 degrees to the horizontal. The dart goes around and it hits the centre of a target 0.25 metres below where it started from. We're not told the distance to the dartboard. Show that the total flight time is about 3 seconds. Now with a show that question, we're not allowed to start with 3 seconds and work backwards. Not allowed to do that. So let's think. How about writing down what we've been told? Let's write down SUVAT. Let's see where it goes. SUVAT. Obviously, we're trying to get t here. S, this is for vertical component, is 0.25. Now, because it's a projectile question, I'm going to have up as positive. So S will be minus 0.25. U is the vertical component of this, which we have not been told. We're going to have to work it out. And it is the sine of 4 degrees multiplied by 9. Sine 4 degrees. Not much, times 9. It's positive, it's going up, 0.6278628. That'll do. V is unknown. Acceleration, we do know. It's minus 9.8. How are we going to get t from this? There are 2 ways we can get t. If you want to get t directly using an equation, what you would do is you say, oh, I know, we're going to use that one which is S equals ut plus half at squared. Now, I would recommend that you do not do this, even though it might be the approved way to get t, because you're going to have to do a quadratic. But let's do it anyway, and then we'll do it another method. Okay? So, what we're going to do is we're going to find t from here. Let's rewrite it. Here we go. Minus 0.25 equals u 0.628t plus a half times minus 9.8 times t squared. Okay, so we have to turn this into a format of a quadratic. So 0 equals, we'll make this one first because that's the t squared bit. Right, so this is minus 4.9 t squared, because of the minus there, plus 0.628t plus, because I'm going to add it onto both sides, it's going to come over here, plus 0.25. So in a quadratic, that is your A value, that's your B value, and that's your C value. And you now get your calculator, and if you've got a TI, I've got no idea what you do, but on a Casio, you press mode, you press 5 for equation, and then 3 for quadratics, basic quadratics, and then you type in the values of A, B, and C. A is minus 4.9, B is 0.628, and C is 0.25. You press equals, wait for a bit. The x1 value is 0.29887. Oh, that sounds good. And if I press it again, I'll get the other value, the x2 value, which is minus 0.17. Interestingly, those of you that get this, the x2 value tells you that if you had projected it back, it would be back at this line 0.17 seconds earlier. But we don't use that. We're going to use this one. And that's telling me that x1 is 0.29887. So it's okay, everyone. Of course, we were after 0.3 seconds, not 0.3 seconds. Sorry, I'm thinking, why does it not agree? It's all fine. Show that the total flight time is 0.3 seconds, and we've just done it. This is terrible. What a terrible way to be doing a physics question. All right, all this work, you make mistakes, you've got to input everything. We should not be using quadratics to solve for t using equations 2 and 3. All right, we just shouldn't be. All right, unless you're a bit of a maths genius and you love this stuff. Why are you doing it? It's horrible. So I'm now going to show you the other way of getting t. Let's do another method to check that total flight time is about 0.3 seconds without killing ourselves doing a quadratic to get t. Let's do it by finding v first and then working out t. If we ignore the t, we're back to our favourite equation, v squared equals u squared plus 2as. V squared's the thing we want. U squared, this number, 0.628 squared, plus 2 times minus 9.8 times s. S is, which direction is s? It's down, minus. Now you can see, hopefully, that what's going to happen is that its final vertical velocity is going to be greater than its initial because I've got a double negative here. So that's all going to become positive. They're going to be adding on a positive number. This whole right-hand side is going to get bigger. So v squared is going to get bigger. And that makes sense because it's gone up in the air, it's come back to where it started from, and then it can fell another 0.25. And you know that the vertical component at that point going down is going to be that anyway. So it doesn't really matter which way around you put the sign on that, because that's going to be 0.628 squared. We're going to end up with a bigger number and we're going to square root it. Let's go! 0.628 squared, 0.394 plus 2 times minus 9.8 times minus 0.25, 4.9 plus 0.394, 5.294. Square root it, 2.3. It's going down at 2.3. So v is 2.3. Well, this has now become very simple. It started up at 0.628, went up, came back down, and then it was doing 2.3. How long does it take to accelerate from 0.628 up to 2.3 down when it's changing speed at 9.8? Answer, you add them together, 2.3 plus 0.628, and then you divide by 9.8. Let's try that. 2.3 plus 0.628, because that's the difference in the velocities, because that's going down and that was going up, and then divide by 9.8, and that gives me an answer of 0.2987 seconds, which is this number here, 0.3 seconds. Now, I don't know about you lot, but I much prefer this. So even though they ask you for time, I mean, unless you really, really want to and feel comfortable, don't go and reach for the quadratic equation. Work out v first. Once you've got v, divide the difference in the velocities by g, and you get time. I think that's a faster approach. Okay, welcome back to PQ25. We're now going to do part CI. Calculate the distance between Olaf and the dartboard. That's the range. Well, that's pretty straightforward because we know that range is equal to total flight time multiplied by the initial horizontal velocity. Let's calculate the initial horizontal velocity. It's a cosine, so it's cos of 4 times 9 meters per second. So that is 8.978 meters per second. Total flight time, we have spent all that time working out, is that. So 0.2988 multiplied by 8.978. The answer is 2.68 meters. That's the range, 2.68 meters, because in the time it took to go up, come down, and come down to this point, that time we worked out at that much, and all that time it was going sideways at cos 4 degrees times 9, which is that number. Multiply the time by that, and we get that. And the next last part, BII, speed of the dart when it hits the bullseye. Okay, so we're going to work out part B, which is, or part BII, speed of the dart when it hits the bullseye. We know that when it hits the bullseye, it's going down at the speed we worked out earlier, which is 2.3 meters per second, and it's going sideways at 8.978, and we're going to use Pythagoras on that, and we're going to work it out. Here we go. 2.3 squared plus 8.978 squared. Square root the answer. 9.267. 9.27. 9.27 in that direction. And it also needs speed of the dart, doesn't want the angle. Sketch graphs. Okay, so BI, this speed here should be higher than that speed there because you have dropped and you've gained some energy from the gravity field. Now we haven't done energy transfers yet, that's coming up, but whenever something has dropped and gone down below where it started, it must have speeded up its total speed. Its speed there is 9.27, when it left it was 9. The difference can be explained by the energy coming from the gravity field on the vertical drop. And in fact, interestingly, you can actually use those energy calculations as another way of working this stuff out. They didn't ask you what the angle was, but in all these situations where you end up lower down than when you started, that angle will be greater because it's doing that. So this angle would be bigger than 4 degrees, maybe 5 or 6 degrees. Okay, that is part B. And lastly, sketch graphs to show how the variation of time with the dart's horizontal velocity, well, that's the easiest one in the whole world, time horizontal velocity. It's fixed at 8.978 meters per second. So that's easy. That'd be whatever, nearly 9. And vertical velocity, well, it's going to be a line doing that. Dead straight line. It's going to start at whatever it started at, 0.628. That line there, when it's doing zeros when it gets to the top, which have been 0.628, about 0.6 of a second, and then it's just doing that straight down. So always, because acceleration is constant, the velocity time graph, vertical, is always going to be a line going down with a gradient of g. It just is. Okay, now that marks the end of PQ25, and in fact it marks the end of all the practice questions involved with projectiles. And that might be what they want for IB students. However, I am aware that non-IB students are often asked more demanding questions. So in the next video, I will be doing a full-on demanding question, which we will solve in the next one. So in fact, what I'll do now, before we do that, I'm going to set you your homework. I'm going to set you a question for you to do, and I'm going to solve it with you next time. Okay, so here is your homework question for those of you that think you know projectiles. It's one of my favourites. There is a cliff and there is a cannon, and it's being fired at 90 meters per second at an angle of 22 degrees. And this is set 60 meters above the sea. The cannon goes up in the air and crashes and lands down over there. I want to know the following things. Maximum height above sea. I want to know its range. How far from the foot of the cliff did it hit the water? I also want to know its speed on impact, and I want to know the angle with the sea. Spoiler alert, because it's going down, its speed will be greater than 90, and the angle will be greater than 22. All right, so that's your final answer, will be greater than 90 and the angle will be greater than 22. Work it out for me and work out the range and work out the maximum height. There are probably 3 different ways you can do this, and I'm going to walk you through them all next lesson. Thank you.